Good morning to everyone. In today's presentation, we will see about two important analysis which will be used in network analysis to analyze any given electric circuit. Okay, so those techniques are one is nodal analysis, and the second one is mesh analysis. Right, the second one is mesh analysis second one is the mesh analysis. Right, the nodal analysis will be used to find out the voltages in that given circuit, as well as the mesh analysis will be used to find out the currents in the given circuits. Therefore, remember that the mesh analysis will be used to find out the currents within the circuit. The nodal analysis will be used to find out the voltages in the given circuit. Right, so now let us see these two one after another. So to understand the concept of this nodal analysis, let us take a simple circuit. How the nodal analysis will be applied for this simple circuit? Let us consider a simple circuit actually, having different resistor value and voltage sources in the given circuit. Actually, this is the simple circuit given, having three different resistors and then one voltage source. Right, so this is plus and then minus. Consider it as 20 voltage is the voltage source we have applied, and here it is a 2 ohm resistor. Consider it as a 1 ohm resistor, and this is as 4 ohm resistor. This is the simple circuit. Find the nodal voltage. Find the voltage. Find out the voltage V. The voltage V. Nothing but that V is nothing but here. This is the V value. We have to find the voltage V. This is the question actually. So to find out this particular voltage, so for your information, so this is the node. Actually, this node is nothing but non-reference node. Remember, this is called as non-reference node. Actually, this is called non-reference node, whereas the other node, normally we will consider this node as a ground point. So this node which we are considering as a common node or as a ground one, that is called as a reference node. Right, this is called as the reference node. Remember this. So in any given circuit we have one reference node, and then you can have number of non-reference nodes, maybe one node. In this particular example, this particular node will be considered as non-reference node. So in the given circuit, depending on the problem, the non-references nodes can be even more than one, maybe 2, 3, 4, 5, whatever it is, depending on the complexity of the problem. Right, in this simple exercise, so this particular node, this is called as non-reference node, and this is called as the reference node. Now, how the nodal analysis will be applied to determine this particular voltage? It's very simple. Normally we use the concept of the KCIL. Okay, normally we use the concept of KCL, is the Kirchhoff current law. Okay, according to Kirchhoff current law, we know the fundamental Ohm's law definition. So we know the definition of Ohm's law, that is nothing but V is equal to I into R, and from this, right, you bring the relation for I is equal to V by R. This we know. Therefore, this formula we have to use while applying the nodal analysis. So I is equal to V by R form we have to write. Therefore, what is that? It is simply nothing but by using this particular I is equal to V by R form, how I am going to write the equation? Let us see. I can write this as like this: V minus 20. So it is V minus 20 by R 2 ohm plus V minus 0. This is the common node. Okay, reference node. Normally it will be at 0 volt. Okay, remember that. Therefore, V minus 0. It is V minus 0 by 1 ohm resistor plus V minus 0 by 4. V minus 0 by 4 is equal to 0. This is what actually, if you observe this expression, it is V by R. V is the nodal voltage which we are going to find out. Minus 20 is the voltage, again voltage, this voltage minus this voltage by resistor, or simply it is V by R form. This 2 ohm is the resistor, V by R form. So this is the V by R form. Again here for this resistor, V by so V minus 0, nothing but voltage only, voltage by R, V by R form, V by R, nothing but what, I only, I is equal to V by R form. I am writing the expression. Therefore, for this simple circuit, you can write the expression like this, and if you can simplify this, you will get. So it is simply V minus, it is 20 by 2 plus it is V by 1 plus V by 4 equal to 0. Now take the LCM of this and you can find out the value V, and just I will erase this circuit and I can write that simplified expression here, right? So if you can simplify this, you will get. So if you take the LCM of for this, what will be the 214? It is a 4 your LCM actually. Therefore 2 into 2 times 2 2s are 4, therefore it is 2 times V minus 20. Clear? V minus 20 plus it is 1, therefore 1 into 4, 4 times, it is 4 into V plus, so 4 into 1 time 4 means 1 into V is equal to 0. This implies if you take the cross multiplication, okay, or otherwise simply if not simply directly, the entire, the numerator part becomes 0, therefore it is nothing but 2 into, or otherwise simply I can directly simplify it. It is 2V minus 40 plus 4V plus V equal to 0. Directly you can write like that, right? So this implies this is equal to 2V, 4V and V. So 2V plus 4V 6V plus 1V 7V minus 40 equal to 0, and this implies it is 7V is equal to 40, and furtherly this implies your V, what is V? So this implies V is equal to, it is 40 by 7, roughly you can have it is something 5 point, you will get a 7 5.71 volt you will get. So this is the answer. This is called as the voltage which is available at that point which is indicated in the circuit. This is what the nodal voltage. This is your answer, right? I hope you understood well, and will be continued in our subsequent presentation. Thank you.